Hello, welcome back to the PyTorch series. So today we're going to talk about how to customize our layers. Okay, so previously we discussed how to make our own module, right? So today we're going to talk about this more specific customizations. Okay, so and then we're going to also talk about how to save and load the tensors as well as the network parameters. Okay, good. So first of all, let's have a look on this customizing the layer, which is pretty simple. That this is without the parameters. Okay, so we're gonna have our x. Okay, so which is the tensor. So let's call this some sort of centralized layer. Okay, which is a module. So where we simply define this forward as let's use this x minus the mean of x. Okay. So then we make an instance of this, and then we're gonna print this new layer. Okay. So where we have this this list. Okay, from 1 to 5, this tensor. Okay. So and then we're gonna have some net as a sequential, which took a linear 2 by 4 and 2, and then we take this customized layer that is without any parameters. Okay, we simply have some operation here, pretty simple operation. Okay, good. So let's have a look at this result. So, and as we expected, so that gives us this, right? So from -2, -1, 0, 1, and 2. Right, and if we just want to print some mean of this, then this gives us this this mean, right? So after we put some net of x. Okay, so this x is just some random 2 by 2 matrix. Okay, good. So okay, so that would be the way of constructing this customized layer, right? So by using this module, right? So that defines some forward layer from here, right? So and this is what we define. Okay, and we could put this simply. We could use this to take some, for example, to take some input like this, or we can even to use this inside of our n sequential, right? So both of those are feasible ways of using this. Okay, good. So next we're gonna extend this customization of layers with parameters. Okay, so for the parameters, so this is also pretty straightforward, right? So we simply like we're gonna define the weights and bias that we need, right? So we have some input feature dimensions and output features. So here we put this dimension for the weight to be as input feature by output feature, right? This is actually not correct, right? So we basically need to have sort of, so this is the, if you recall from the previous episode, we have this dimension. If we put in first and out later, so this is gonna be the dimension for example, for n linear, right? But for the simplicity of computation, so we put this as the same as what we did in linear, right? So that we don't need to make a transpose here and another transpose here, right? So then this simply, so here we shouldn't really call this as weight, right? So this should be called like the transpose of weight, but we just know this. Okay, so that'll be fine. Good. So and correspondingly we have this bias, so that simply has one dimension with size of output features. Okay. Now we're going to define just one forward layer, so that'll be linear. Okay, and we call this as linear, which is simply just a matrix multiplication. Okay, with x, so x is the batch size by input feature, right? And this has to be input by output. Okay, so that gives us the batch size by output. And then we have a ReLU here. Okay, so that we can see that here, normally if we put the weight right here, right, so we need a transpose, but since we define this in sort of in quote-unquote in a wrong way, right, so we define this in by the input feature first and output feature here, so we don't need the transpose. So this is exactly the same as what we did for the NN linear, right? So this is sort of like the way of doing that, but we just know this, so that we don't have to worry about too much for this. Okay, good. So that would be the definition for this prime layer. Okay, so now we're gonna have some let's say we specify the dimensions. Okay, so be 2 and 3. So this will be some net, right? So this will be some module actually. So this module has the weight and bias. So that would be simply just this bias weight. That would be just the one that we defined for this linear, for this layer, right? Okay, and I'm gonna take some x 4/2. And then use this to have some output. Okay, so let's first have a look on this. So this x. Okay, so let's see. This is gonna be the weight that we defined, right? So this is the bias, and those are already in the dimension that we ask, right? 2 and 3. So then we're gonna have this. This will be the print of. Let's see. Okay, so this is going to be the parameter net of x that we printed, right? So after we take x into this parameter net, then this will be the output. Okay, good. So this is one way of customizing our own layer, right, inside our module. So, and this is how to use this to do some forward computation, right? Forward. So this will be feed forward, right? And then we can also use the customized layer to help construct a sequential module, right? So we can even put this inside of a sequential, right? So this is also a sum module, right? Remember, we defined this as a module, so this is also a module, so that will be able to fit inside of a module, which is sequential. Okay, so we're gonna say this has a 2 by 1000, and we're gonna put the ReLU, and there's a prime layer, this again. Okay, just make sure that the dimensions they match here, right? And something important to notice is that we can put n.ReLU here, but if you want to put some ReLU, for example, in here, so you have to use the f.ReLU, right? So, and this is capitalized and the other one is not, right? So just be careful of those little small details. Okay, good. So it's just the different ways of defining the ReLU, right? Using different kinds of class or functions. Okay, good. So the result of this, that would be this, right? So this would be the output from this sequential. Okay, good. So then we're gonna next introduce the way of saving and loading the tensors from files. Okay, so for example here we have this x to be a range of 5, so that will be something like this. Okay, and then we save this. Okay, we're gonna simply call this x as x file, okay, which is saved here, and we're gonna load this and put this to some new variable. Okay, so that's it, right? So this is pretty straightforward. And we can also save this as a list of tensor and load that. So for example, we have this x to be towards a range 5 and y to be towards 0 is 5, then we're gonna put this x and y in the list, and let's save that as a file called xy file. Okay, and we can load that to two new variables. Okay, this is also pretty simple. And we can even also save this as some dictionary. Okay, and let's call this. Let's put those values to those keys, which have the same name. Okay, and then we're gonna save this dictionary, and we can load that. Okay, so let's print this, and that'll be exactly the same as before. Good. Okay, so next. Okay, so next we're gonna. So here we have something missing. So this would be save and load the network parameters. Okay, good. So let's have a look on this. So we're gonna first define some pretty simple forward network that'll be having this hidden. Okay, and we're gonna have value and we're gonna have an output. Okay, so this is pretty simple. And then so we're gonna save this. Okay, using, so we're gonna load this. So we're gonna read the state dict first, right? So this returns all those return dictionary, right? And that contains the biases and weights that we have in this network. Okay, and then we're gonna save that to this file. Okay, and then so that'll be this, right? So, and then we can load that. So something important to notice here is that, so in PyTorch we can only save those parameters. Okay, so let's have a look at those parameters. So that'll be those, right? So this MLP, those parameters. Okay, so and it cannot save the sort of the so-called architecture or the network structure, right? So that's not easily that's not quite feasible in PyTorch, but we can always find a way to do that, but it's not pretty straightforward. So it's just easier to save the parameters in PyTorch. Okay, so that means if we want to load, okay, for example here, if we want to load some parameters, so we're gonna first need to define a new network structure, right? So we're gonna first define some new network that we want as the same structure as we defined before, right? So if you want to load this parameter into this new variable, into this new network, you're gonna first define this new network as something that has this proper network structure as you want to load, right? So that this structure can match those parameters. So this is very important in PyTorch. Okay, so then we're gonna define this MLP first, and then we're gonna load these parameters. So using this sort of called load state dict, okay, and then load those parameters, okay, from this file. Okay, and then we can call this as Z after we read this parameters, and then we take X again into this. Okay, and we want to verify if we have the same result as Y, and we can also print this if this should be the same as Y, and it should return all the truths, right? And yes, we have all of those matched together, right? So that is just something that we can do for saving and loading the state dict, right? So all those network parameters, including the biases and the weights, right, from this MLP. Okay, good. So this is pretty useful, right? And so that'll be everything for this episode. Okay, so today we discussed how to customize some layers, right, with or without any parameters, and we also introduced how to save and load the tensors as well as the network parameters, right? And something important to notice is that we're gonna when we need to load the parameters, we need to first define some network that you want for those parameters, right? So that you can load those parameters after you define this. Okay, so that will be everything for this episode. Okay, hope this will be useful. Good.